On Notes 2.5, we're going to be looking at compound interest again, the compound interest formula, and also the continuously compounded formula. Okay, so just a reminder on the formula, A is your final amount. P is your starting amount. R is your rate as a decimal. N is the number of times per year. And then T is your time in years. Okay, so just like before, I want you to write down your variables on the side and fill in what you know and then solve for what you don't know. It says if Courtney wants to have $5,000 in an account after 12 years that earns 7% interest compounded quarterly, how much will she have to invest initially? So starting out. So on the side, write down your variables, A, P, R, N, and T. Okay, so A is your final amount, so we know that she wants to have $5,000. We don't know the starting amount. The rate that it's increasing is 7%, but we need to change that to a decimal, which would be 0.07. And then N is the number of times it's compounded per year. It says quarterly, which is 4 times a year, and it's over a 12-year period. Okay, so we're going to plug in. So I know A is 5,000, and we're looking for P. The rate is 0.07 over 4, and 4 times 12. Okay, so we're trying to solve for P, which means I need to get rid of all of this. So I would have to divide that. Instead of rewriting, I'm just going to draw some arrows, so I'm going to need to divide it. So on your calculator, we're going to have 5,000 divided by, we need to put parentheses around all this. And then I'm going to go ahead and open up another set. 1 plus 0.07 divided by 4. Close that. And then I need to raise it to the 48th power. And then you should end up with your P. So P would equal, we're talking about money, $2,174.29. To check it, you can plug it back in. It should give you 5,000. Alright, number 2. Suppose Heather has $2,000 to invest in an account that earns 10% interest compounded semi-annually. She wants to leave the money in the account until it has grown to an amount of $5,000. How long must she leave the money in the account? So again, write down your variables. A is your final amount, which is 5,000. P is your starting amount, which is 2,000. The rate that it's increasing is 10%, so that would be 0.10 as a decimal. And then it's compounded semi-annually, which means twice a year. And we're looking for the time. So I'm going to plug into my formula. 5,000 equals 2,000. And then I have 1 plus 0.1 divided by 2. And then the 2t power. Okay, so notice on this one, this is something new. We haven't ever solved for part of the variable or exponent, okay? So what we're going to do is we want to isolate the base and the exponent. So this is our base and exponent. So your first step, if you're solving for part of the exponent, is to divide by 2,000. I'm just going to write that as 5 over 2. And I need to figure out what inside the parentheses that is. So I'm going to do 1 plus 0.1 divided by 2. and we should get 1.05 to the 2t power. Okay, so this is called an exponential equation because we're solving for t, which is part of our exponent. Okay, so we've just talked about in order to solve an exponential, we take the log of both sides, so that way we're able to move that exponent in front. So I'm going to take the log of 5 over 2. I'm going to bring this exponent in front, so 2t log of 1.05. And then we're solving for t, so I need to get rid of the 2 and the log of 1.05. Make sure that you put parentheses around all of that if you're doing it all at once in the calculator. So that cancels and that cancels. Okay, so we have log of 5 divided by 2 divided by, open parentheses, 2 log of 1.05. So we end up getting t equals, we'll round to 3 decimal places, so 9.390. We're talking about years. Okay, so the only thing different than the last time we went over this is we're having to solve for part of the exponent, which means we have to use logs. Okay, so 3, it says if Scott invests $6,000 at 8% compounded quarterly, how long will it be before his investment has grown to $14,000? So A is your final amount, so which is 14,000. P is your starting amount, which is 6,000. The rate would be 0.08. N is the number of times it's compounded per year. It says compounded quarterly, which means 4 times a year, and we're looking for the time again. Okay, so just like the other example, we want to get the base and exponent by itself. So I'm going to divide by 6,000. So that would be 14 over 6. So that would be 7/3. And then we're going to find 1 plus 0.08 divided by 4. So 1.02 to the 4t power. Okay, so now we're solving for t, which is part of the exponent. So now I'm going to take the log of both sides. Do that, I'm able to bring that exponent in front. So 4t log of 1.02, and then we will divide by the 4 log of 1.02. Just make sure if you're doing it all at once that you put parentheses around that 4 log of 1.02. So we have t equals, plugging it in, we have log of 7/3 divided by, open parentheses, 4 log of 1.02. Close that set and then close one more. You should get 10.697 years. If you wanted to check any of these, you could just plug it back into the formula. So do 6,000 times 1 plus 0.08 divided by 4, raise that to the 4 times that answer, and it should give you 14,000. So you can plug it back in and check it. Okay, let's look at the back. So remember when we were going over compound interest formula, we also went on, or we went over a continuously compounded formula. A is going to be your final amount, just like the front. P is your starting amount. R is your rate as a decimal. And T is your time in years. So same thing. The only thing different is there's an E in the problem, and remember that's a constant. So we have that E button on the calculator. Okay, so 4, it says, suppose you plan to invest $2,500 for 5 years at an annual rate of 7.5%. Find your total amount of money if the investment is compounded continuously. That's when you know which formula you need to use. It says continuously. So I want you to write your variables down. A is your final amount, which we don't know. We know the starting amount is $2,500. The rate is 0.075, and it's 5 years. So this one's pretty easy. We're just plugging in. E to the 0.075 times 5 power. So we're just typing all of that in using the E button on the calculator. So we have 2,500. And then your E is second divide. And then my exponent is 0.075 times 5. A, which is your final amount, should be $3,637.48. So make sure it's talking about money, that you're rounding it to the nearest cent. Alright, last one. What annual interest rate is required to double an investment of $1,000 in 3 years compounded continuously? So using the same formula because it says continuously. A is your final amount. We're starting with 1,000 and we're doubling it, which means your final amount would be 2,000. The rate we don't know. We know the time is 3 years. Alright, so plugging in, we have 2,000 equals 1,000. We don't know R, and we know T is 3. Okay, so notice we're solving for an exponent again. So we're going to need to isolate the base with the exponent, which is the base is E. So we're first going to need to divide by 1,000 on both sides. So you get 2 equals E. I'm going to go ahead and write that instead of R times 3. I'm going to write that as 3R. Okay, so now, in order to get rid of the exponent, make it a coefficient, I need to take the log of both sides. But notice we have an E in our problem, which means we need to take the natural log of both sides. And I'm going to go ahead and write the 3R in front. So I'm needing to get rid of the 3 and the natural log of E. So natural log button is to the left of 4. So natural log of 2 divided by open parentheses 3 natural log of E. So make sure that you're putting parentheses around the 3 natural log of E. Okay, so this is a rate as a decimal, but normally we're given that interest rate as a percent. So we need to change it back. It would be 23%, because that was a 1 there. So 23%. So if you're finding the rate, that's a decimal, you would need to change it back to a percent there. You can always plug it back into the original to check it.